Oh.
Click on the different screens,
And
go
see.
to recipes, get acclimated with it.
So whenever something comes here, operation vacuum, everything has to be on like this one, right? So
Have to be pumping, have to have gas flow,
yes.
your manual valves have to be open, and have to be heated.
Alright, so we have to start from run recipe and LD heater recipe. This one, right?
That's what you have now.
That's what we have to switch on for the recipe.
It's for heating. Yep.
Run recipe, that's okay?
Yep. I'm going to start building you a small folder.
So this recipe tree is based on whatever recipe are available in the recipe editor. This thing.
That's from that recipe.
Editor, right?
That's all the steps in the recipe editor.
These are from here. Whatever you have showed us earlier.
Yep.
So this one was what I learned is editor recipe. Okay. Yeah. This one, right?
That is the heater. Yep.
Right.
And you click on that.
So this will run as soon as I say run.
That'll put the set points and turn the heaters on.
Yeah, I mean based on this one.
Yeah, that's the one you have.
Like 41 recipes will run.
There's 41 segments in that recipe. It's not 41 recipes.
Okay.
There's
In one
41
recipe.
steps.
41 segments.
Yeah.
So 41 segments will run.
Yes, 41 steps. The step can be a recipe.
Yeah.
So a sub-recipe, if the sub-recipe has 10 steps, you only have one line on the master recipe, but you have 10 steps in that sub-recipe.
It is all parts of one recipe.
One recipe. That's for
Now in the configuration, you see an R on there?
RES.
Okay, click on that. So in this heating recipe, that's what gives it a ramp rate. Before on the heater screen, you could put a ramp rate and the set value. This does it in a recipe. That's how it looks like whenever you have a ramp in a
Around
recipe.
10.
That'll be 10 units,
Yeah.
or
This
10
goes-
degrees over a minute. So that R is a ramp. So you have G, a T, G is go, T is the time value, A is there's an abort step, R will mean there's a ramp, or if you skipped it, you also see an S. So those are all the letters you'll see in that column, or none at all.
A is for abort. T is for time. S is for
Skip,
skip. And another one, G, T,
R, R is
R.
for ramp,
Round.
and G is go to.
Yeah, good. So these are the configuration available in the recipe editor.
In that column. So the ALD process will use an R for a ramp for heating. In the PVD system, you could have an R for power. Where if you wanted to ramp up on power, R in the software would do the same thing.
So S, there is no skip here, so
You don't have to skip. Those are skipped. So there's
Yeah,
an S there because it's skipped in the column preceding. See the check mark?
yeah.
So that's skipped.
Oh, this one is not.
Not skipped, so there's no S.
Oh, okay.
You get used to seeing it, and the manual covers that a little bit. whenever you go through the manual, more pieces will start to set.
So whenever I want to go back to here, I have to click this one.
Well,
to exit from here, from this
the
window.
recipe editor gives you all the recipes.
Yes, if I want to exit from here and go here or somewhere, recipe, I can click this one.
Yeah,
Directly.
look at it. Or if you want to just look at the screen,
Where is that?
click on one of the screens, up the vacuum deposition process.
Right.
Yeah.
Oh, okay.
Yeah.
All right.
So, generally, what metal oxide is better to be deposited using the soldering, and which one is better to be deposited with ALD?
It depends on what you want to do, what characteristics of the film you want to have. So if you want to have a barrier layer on a sample that you're going to stick in an etching source, I would use that, because you can put a thick layer fast as a barrier layer for your next process. I wouldn't use the ALD tool as a barrier layer because it's slow and the chemistry is more expensive. So, and that's what I would use.
Is another aspect, you are right. Okay. But though I see that target for some of the material are also very expensive. For example, the target the bulk around this here for vanadium dioxide was something around 2,000.
Yeah, but you're getting a lot more material.
But yeah, many depositions.
You're talking ounces to grams.
You're right. Definitely.
Now with that, oh, that's a good point. With that, especially if you're using precious metals in here, we'll recycle that. Kurt Lesko will recycle that. So if you have a gold target or a platinum target in a sputter system, you don't etch the whole thing. You etch what's called a racetrack. You etch part of it. So if you get to 75% of your life of your target and you're running gold or platinum, you can send the target back to Kurt Lesko and we'll give you, value on the reclaim of that precious metal.
Yeah.
So you could do that and then get another gold or platinum target or whatever.
So once I did this, the next step will be PC pump. The steps in recipe.
It'll start it.
What's that?
If you click on one of those, it'll start it or you'll get a pop-up. Like in a process recipe, any
Now,
step.
now I switch on the machine. I'm inside the machine. So the procedure, I should start from real recipe, then keep doing this one, right? Now I'm switching. After switching on, and maybe after 2 hours, after the heat is already done or whatever.
Yeah, I would check the gas bottles are
Right,
open,
right.
compressor's on,
Right.
manual valves are open, then you can run the process.
So, using ALD, this system, can be deposited just aluminum, not aluminum oxide.
No,
Just metal oxide. Am I right?
you have to have a reaction.
Exactly.
With the PMA, if you just ran a PMA, once your aluminum is grabbed on to all your sites, that's it. You don't build anymore.
Yeah, so as a conclusion, I need to come to some information. As a conclusion, it's not a good system or it's not possible to deposit metal, just metals, not metal oxides.
I wouldn't use it. You can't use it to just deposit metal. It means there's no reaction. If you want a film buildup in material, this will give you a film of whatever.
What is
Okay.
possible?
This builds a film. This deposit, this grows. You grow films here. You build films there. So in order,
What is the difference? That's very important terminology. This is growth system. This is, you are right. So what does that mean?
this per cycle, you build one monolayer. You can't have another monolayer unless you have another cycle.
Yes.
That just builds and builds and builds and builds. That piles on. This, the two precursors react, one monolayer. Two precursors react, second monolayer. Two precursors react, third monolayer. That just rates. Rate in time. Like shovel. Like, yeah, that's like shoveling material. This is building, 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 building.
Yeah, that's why.
So, yeah, well,
It's like additive manufacturing.
Yeah,
Add
actually,
layer by layer.
that's atomic layer deposition. So, we're on Wi-Fi, right?
yeah.
Let's do that. There we go. Real simple.
Moving to YouTube. Are you trying to do that?
Yeah.
Actually, I think I'm using the same thing. This will explain what happens.
ALD process? Would this have capability to add like ozone?
Yeah, you can add ozone to this.
To this? Okay. Because I saw one article on the IPO, they use ozone.
See, this is a really complex structure. But yeah, you can add ozone to this system.
You know how much roughly cost?
I don't know. Your next precursor reacts. Parts of the molecules break off, they go to the pump. Now you have one solid pinhole free monolayer. Your second precursor comes, reacts, some of the molecule breaks off, and this is your cycle. Then you have a purge time, then this is a dose time. The reaction. Once you react it with all the sites, there's no more reaction. That's what the term self-limiting. So you can build layers like that. Again, no holes. That you're going to have holes in your layer.
It's some sort of additive manufacturing company.
Yeah, it's another manufacturing.
Yeah.
It is. Yeah.
Atomic level.
See, in this, you can have, again, conformal and pinhole free. So you can get in all the little nooks and crannies and super, super small areas. You can have very high aspect ratios and have a conformal coating all the way through any type of three-dimensional unit. It's very difficult to do there. It's good to do here. So this is half new MOSFET, but it's a very similar process.
So basically, if you look at the one example we cut, right? Let's say this one. So you're gonna place them this way in the chamber, but it won't grow inside.
Yep, it will. As long as we can close it, it'll grow. Maybe not so much on the bottom where it's touching the substrate heater, but the rest of it will grow, yeah.
So how do you deal with that? You just have something spacer?
You can, yeah.
Is there a typical way you do that? If you want to coat it all around?
That's how I would do it, yes. And then this way, instead of using the substrate heater to heat your sample, you're using the reactor as an oven. So you don't have any very direct latent heat transfer by convection because you're not touching so much. But you have a whole lot of latent heat transfer via radiation because of the oven. So yeah, you would have to have longer time for thermal equilibration. But yeah, you can do that. Or you have a
But
little.
your thermocouple only monitoring the heater substrate.
True.
So
Just give them enough time.
if we put this sample, the chamber inside the bar will be coated?
Yeah.
Yeah.
In here, not in there.
I know.
So that was it is glass. It will go. This one is direct. What is it?
The entire volume of that chamber will be exposed to the material.
Yeah. So you can have essentially a nanoporous structure, three-dimensional, and still coat everything in and out, and very conformant.
So yeah, that's the biggest advantage of this one.
One of the very big.
Yeah.
That's one thing this can do that that
Yeah,
can't.
I mean, regardless of uniformity, I consider this one the biggest advantage.
Yeah, uniformity, the ability to have a uniform conformal coating in three-dimensional substrate. You can do here.
Three-dimensional coating.
Not there. You're not going to have
That's
conformal coating.
correct.
on that.
It's three-dimensional coating.
Yeah. So if you have this, essentially, if you wanted to coat inside here, and you put this here, and you had the butter gun, you're going to coat a lot around here.
Yeah,
But up in there, you're not going to get a
Yeah,
whole lot.
no.
Everything on.
For a whole lot of reasons. Here, you'll have a chance of doing that. Now, most of the structures that go in there, you can't see. You can't